Okay, so today we're in sections 1.4 and 1.5. We're subtracting integers and rational numbers. So remember, integers don't have decimals, okay? Then rational numbers are decimals and fractions. We're just applying those rules to integers, decimals, and fractions today. All right? So, just like we just rehearsed, we do have some rules for adding and subtracting. Rational in numbers and integers, same sign, add and keep, different sign, subtract, take the sign of the larger number, then you'll be exact. Okay, and we'll keep rehearsing that. So, leading into example 1, all right, we are going to subtract these integers. We see a ton of subtraction signs, right? Okay, and the way our brains are taught to think, we see something like number 1, we see this minus sign between the two numbers, and we think, well, that's subtracting, and then we think that 4 is positive. 4 is not positive. 4 is negative. Okay? This subtraction sign in front of the 4, what we say is every number has a sign. Every number. It's either positive or negative, and the sign is in front of the number. So because that subtraction sign is in front of the 4, guess what? It's negative. Okay? So it might take your brains a little bit to kind of train it. I know. Because the subtraction sign's in front of the 4, that means 4 is negative. Think about it this way. You're taking it away, aren't you? You're taking 4 away from 1. Are we not? That's negative. All right? Am I blowing your minds yet? You get that? We're taking 4 away from 1, which means it's negative. So that subtraction sign means 4 is negative. So, here's the question of the hour. Is this same sign or different? It's different. 1 is positive and 4 is negative. So we are going to subtract them, 3, and take the sign of the larger number. And now I know I'm exact. Okay, right? All right, so that's going to be negative 3. These rules are just a lot of practice, so I'm not going to keep repeating. We're just going to keep moving forward. Just hang in there with me, and I can almost guarantee it, you guys will be good to go by the end of the lesson, okay? All right, negative 5 minus 2. Is 5 positive or negative? Negative. It's negative. Is 2 positive or negative? Negative. It is negative also. Because of the subtraction sign in front of it, that means 2 is negative. So is it same sign or different? Same. So I add them and I keep my negative. See, you guys are already doing better. Okay? Now we see something different in number 3. In number 3, we see 2 negatives back to back with no number in between. This is what we call a double negative. You must always change a double negative to a positive. All right, so last class, everybody kind of preferred this way of doing it. I don't care. You can make it a giant plus sign. As long as you're telling, yes, it is beautiful, okay? You're telling yourself, yes, these cancel. This double negative cancels because that changes what your answer is going to be. Now that it's a plus sign, now that it's 6 plus 5, you don't necessarily have to write that. It's just, I like kind of cleaning it up. 6 plus 5 is what? 11. If you had tried to subtract it, you would have got the wrong answer. Okay? You have to change those double negatives. So what happens if a double negative's out front? The same exact rule applies. Anytime you see 2 negatives with no numbers in between, those cancel out and make it a positive. All right? So now we have 7 minus 3. And what's 7 minus 3, guys? 4. All right, so I've kind of warmed you up on this. Now I want you to do the second column. Numbers 5, 6, 7, and 8. Okay? Catch those double negatives. Change the double negatives to positives before you solve. Okay, I'm going to just do a quick walk around. I won't have time to get everybody. I'm going to try to do half the class on this one and then the other half on the next slide. All right, so everyone together, what's 3 minus 12? Negative 9, okay? So we're already recognizing 3 was positive and 12 was negative. I'm taking 12 from 3. That's going to be negative, all right? Negative 9. Did you catch the double negative? Did you change it on your paper? Not just mental math. I would really encourage you to do that so you don't make a simple mistake. Now I can see 8 is negative, 13 is positive. Again, I like to rewrite it because I just like seeing, kind of the cleaned up version. 5. All right. Double negative again on the next one. 9. All right. And what's the last one, guys? Negative 8. All right. How do we do? Did anybody miss 1 or less? 1 or less? Raise your hand if you missed 1 or 0. 1 or 0. Okay, good. Everybody, yay. Good job, guys. All right. So, integers, that's out of the way. Now let's look at fractions. So, with the fractions, I'm just going to use my same rules, but I also have to make sure I have a common denominator. Okay, so before I can add or subtract. But before I do that, I see what in the first one? What do I see in the first one that I know I need to take care of? Hadley? That double negative needs to change to a positive. Now I have 1/3 plus 1/3 is 2/3. Okay? Not too bad, right? Just using my rules for positives and negatives. Okay, does anybody remember what I said yesterday about mixed numbers? Just across the board, we're always going to, what? Hadley? Yeah, we're going to make them improper, okay? So that way there's just no confusion. I'm not trying to figure out the borrowing scenario because I'd have to borrow to do 1 minus 2, and I just don't want to do that, okay? So we're going to make this an improper fraction. 3 times 3 is 9 plus 1 is 10. That's where I got the 10 from. Okay. Y'all with me? Following how I got 10/3? Negative 10/3. Okay, so now I can bring my denominator across and I can simplify my numerators. What's negative 10 minus 2? Joel? No? Is it same sign or different, guys? 10 is what? Negative. And 2 is negative. Same sign. What is it? Just tell me.
Negative 12.
Negative 12. Negative 12. Ooh, can I reduce this?
Yes.
Yeah, negative 12 over 3 is negative 4. Negative 4. All right, so this is just practice, guys. This is like our warm-up. Then the homework is more practice, more warm-up. So lots of time for us to kind of work through some of this. Okay? All right, what do we see on the next one that we need to deal with? What do we see? Come on, I need more volunteers. What do we see? Okay, mixed number and the whole number too, right? So the whole number, we're going to put over 1. The mixed number, we're going to change to an improper fraction. Go ahead and do that, please. All right, what is it? 11 over 2, right? Okay, so now before I can subtract, I need to change this one to 8 over 2 minus 11 over 2. And what do you get? Negative 3 over 2. And you can leave it improper, okay? You don't have to change it back to a mixed number. Negative 3 over 2. All right, so here we only had to do an LCD once. But again, we're just using our rules for same sign and different signs, okay? So we did integers, we did fractions, and now what? Now what?
Decimals.
Decimals. Okay? If you remember back to yesterday, we talked about subtracting decimals, okay? So that's going to come into play again here. The first thing we need to decide, is this same sign or different here? Same sign or different, guys?
Different.
Different signs. 2.4 is positive, 5.6 is negative. Because they are different, you have to subtract them. and the bigger absolute value has to go on top to subtract. So 5.6 minus 2.4. Subtract them and then decide what the sign of your answer is going to be. You need to decide. Samuel, what'd you get?
Negative 3.2.
Okay, do you agree with him?
Yes.
Yes, because 5.6 was bigger and it was negative, so my answer is negative after I subtract. All right, let's look at this next one. Same sign or different? It's different again, so I need to subtract them. Which one has the bigger absolute value? Yes, why 0.5? Why 0.5? Technically, 4, 5 has more digits. Yes.
But when you add the 0 to 0.5 and match it, it's 5 digits.
Yes. He's saying because there's 2 digits in 45, I put a 0 behind the 5, and now that makes it 50, and I can see it's the bigger absolute value. Go ahead and subtract them and decide what the sign of your answer is going to be. Okay, so we already did the first one. Now, when we subtract, did everybody get negative 0.05? Okay. Now, on the top one on the right, okay, most of us have already done that one. What happens to that double negative? Changes to a positive, and now we see what? They're opposites. Does anybody remember the fancy word we learned yesterday? Joel? Raise your hand, you don't remember.
I pulled a Dory.
Additive inverse, okay? So you're going to see that come quiz and test time, that fancy word, additive inverse. So if I ask you the additive inverse of 4, you would say negative 4. It's just the opposite, okay? All right, so we see opposites here. Negative 8.8 and positive 8.8, 0. Easy enough. And then 4.9 minus 1.6 is 3.3. All right. Good? Thumbs up? Okay. All right. Now, you're going to see problems come up from time to time, and what they're trying to kind of reinforce to you is this whole idea of the commutative property. We can rearrange numbers to make it easier to solve. Anytime we see fractions involved, we immediately want to combine like terms, okay, wherever we can. All right, so, I'm sorry, not combine like terms. Combine the common denominator ones first, okay? So on this first problem, all right, we see 2 sets of fractions here with the denominators of 5. So I'm going to focus there first. Negative 2 over 1. I know that's going to become a fraction at some point. Minus 2 over 5. Plus, what is this one as an improper fraction? 8 over 5. Okay. So now let's combine these first because they have a common denominator. What's negative 2 plus 8? Go ahead. That's okay. 6, right? So negative 2 over 1 plus 6 over 5. All right, am I ready to add them together to get my answer? Am I? No, what do I need? Common denominator. So 1 times what? 5. So my denominator becomes a 5. And what is my numerator? Negative 10. Plus 6 over 5. All right, remind me again, do I need to add my denominators together? No, just bring it over. And what's negative 10 plus 6?
Negative 4.
Negative 4. And we're done. Okay, good job, guys. This is one of the tougher parts of the lesson, okay? But we can do it. Look at the second one. Take a minute, kind of digest it. All right, what do you think you're going to do first? Jack?
Subtract 7.8 and 3.3.
You can. Nothing will be affected. I see something there, though, that's going to really kind of change what's happening here. Alexa?
Change the double negative.
Yeah, very good. I want to knock out that double negative and make it a positive. Okay? And you can just do it right there in the original problem. Just remind yourself, hey, that's a positive there. Okay, now we can go back to what Jack said. We can subtract 7.8 minus 3.3. You can do that by hand or you can do it mental math. We know 7 minus 3 is what? 4. And then 8 minus 3 is 5, so 4.5 plus 1.2 plus 4.3. All right, now again, you can add these out of order. That's why they're putting this in this slide. You can add them in whatever order you want, or you can just add them from left to right. Okay, what would you do, Samuel?
I just added the fours together, then the 1.2.
Yeah, you could, but I wouldn't add them all together unless you do it vertically. Okay, if you line them up vertically, but you could. This is what I did. I did 4.5 plus, and then this was easy for me too. I added the 1 and the 4 to make 5.5, and then when I add them together, I get 10. Okay, now guys, there is not just one way to do this. I don't care which way you do it. The main thing I want you to look for here is just look for opposites. These examples really didn't have a lot of that going on, but they very well could on your homework worksheet tonight and a quiz or a test. So look for those opposites to cancel. Okay? Now, this next slide is not in your notes. Okay? I just added it in today, actually, just thinking through how to teach you guys how to find distance in the easiest way. Okay, so it seemed to go over well in 4th hour, so we're going to give it a shot here. Okay, so we find distance relative to a number line. So basically in reference to a number line, what is the distance between 2 points? So I'm just going to give you 2 points, but before we do that, what do you think is our basis or our benchmark on a number line? What's our starting point on a number line? Yes? 0. Okay, so 0 is our starting point. It always is. So here's my rule. If my two values that I'm trying to find the distance between, if they are both on the same side, so they're maybe both negative, I'm going to subtract their absolute values. That'll make more sense when we start doing them. If they're on opposite, one is negative and one is positive, then I'm going to add their absolute values. All right, so let's start with opposite sides of the 0. Now, anytime we're finding distance, distance is always positive. I want you to remember that too, right? Okay, so there's no such thing as I ran negative 3 miles today, even if you ran it backwards, right? You still ran a positive distance, okay? So we need to keep that in mind too. So what if we started at, let's say, and ignore the dashes because I'm gonna go like way off on this. Negative 15, and I wanted to find the distance between negative 15 and positive 10. Okay? Well, how many units get me from negative 15 to 0? 15. How many get me from 0 to 10? 10. So to find the distance between the two, I would add them together. And what is it? 25. Okay, so instead of doing all of that on a number line, if I know one is negative and one is positive, meaning they're on opposite sides of 0, I just add them together. Okay, so let's do another one on opposite sides of 0. Negative 8 and 5. What's the distance between them? 13. Because they're on opposite sides of 0, one's positive, one's negative, add them together. 8 plus 5 is 13. All right, let's do another one. Negative 2 and 10. Did I already do that one? No, I didn't. Okay, what is it, guys? 12. I just add them together. Are you guys catching on? I just want to know how many units are between them. Of course, they're going to put fractions and decimals in there too, but we'll stick with whole numbers for now. Okay, so now what if my 0 is over here and I have a negative 2 and a negative 10? Okay, so now both values that I'm comparing are on the same side of 0. They're both to the left of 0. Would you agree? So now I'm going to subtract their absolute values to figure out the distance between them. What's 10 minus 2? So there are 8 units between them. Okay? So let's do another one. Negative 20 and negative 10. Okay? So they're both on the left side of 0, the same side of 0. So what do? Subtract. How many units between them? 10. All right, how are we doing on that? Okay, so don't get it confused with your other rules, but I think honestly that might be the easiest way to find distance. All right, so this is what it's going to look like on your homework, on your quiz, and on your test. Find the distance between the two numbers. All right, so are these two numbers on the same side of 0 or on different sides of 0? Different, so what do? Add them together. So how many is between them? 12. And you're done. That's it. Okay? Now you have a fraction. Okay? The first thing you need to do is decide same side of 0 or opposite sides. Same side of 0. So because it's on both negative, both on the same side of 0, I'm going to subtract their absolute values. I need the bigger one to come first because I don't want a negative distance. Okay? So anytime you say, oh, I need to subtract, okay, they're on the same side of 0, you always put the bigger one first. So 2 minus 1/3. Okay? Well, I need to change my 2 to make the same denominator. So I'm going to say 6 over 3. That's the same thing as 2. I multiply top and bottom by 3. Minus 1 over 3. Why did I write a 4? I'm like thinking 2 steps ahead. Okay. What's 6 minus 1? 5/3. Okay. And that is the distance between them. I can leave it a fraction and I'm good to go. All right. How do we do on that? Okay, we are going to stop there for today. We did have one more elevation example, but it's very similar to the distance. We'll cover it tomorrow if we have time. But that's really everything we need to know for the worksheet. And so we'll go ahead and end there so we can start our worksheet.